The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy like the Milky Way. Our knowledge of the universe grows a lot every year as scientists all over the world make amazing discoveries that change what we know today. We're going to talk about some of the newest and less well-known discoveries that even the most experienced experts can't figure out. Join us as we explore the depths of space and find secrets that help us get closer to solving some of the most important questions in the universe. Imagine that a planet was found in the outer parts of our solar system that follows its star backward compared to other planets. Not only would such a find be interesting, it would also call into question current ideas about how planetary systems form. Researchers have recently found some of these strange exoplanets. For example, some orbit their stars in very close orbits which make the surface very hot and able to melt metals. Others are rogue planets that wander through the galaxy without a star. This makes people wonder where they came from and how they stay alive in the hard environment of space. Understanding the complexities of these mysterious heavenly bodies greatly expands the field of science. This has effects on both academic interest and practical issues such as how we might live on other worlds in the future. Each new finding is a key piece in putting the big puzzle of the universe together. Think about what it would mean to find water vapor on a faraway world or to find a planet with an atmosphere like Earth's. These results could show where conditions are right for life to start, which could help plan future trips to these faraway places. Understanding the unique shapes and behaviors of these planets also helps scientists improve their models of the structure and development of the universe. This gives us clues about the past and future of Earth. Imagine that we find an exoplanet whose path isn't smooth, which goes against current theories of gravity and makes us question what we think we know about physics and how things move in space. Not only is this kind of information useful for school, but it will also have long-term effects on technology and space research. The finding of 27 or 10, the largest world in our solar system that hasn't been named yet, is an interesting case study in how to find and study celestial bodies. This faraway object, which is in the scattered disk region beyond Neptune, gives astronomers both new tasks and chances. Astronomers found 27 or 10 for the first time while using the Samuel E. telescope at Palmer Observatory for a regular check. It was confirmed to have been found by looking at prediscovery pictures made by the Spacewatch project. This shows how space science is often collaborative and like a detective story. 27 or 10 is the third largest known dwarf planet in our solar system. Its diameter is about 1,535 kilometers, which makes it a very big planet. Even though it is very big, it doesn't have a name yet because we don't fully understand its orbit and haven't been able to figure it out enough to meet the International Astronomical Union standards for naming objects. Its surface is mysteriously dark and red, which suggests that it contains complex organic compounds called the lin. These are made when sunlight hits simple organic compounds like methane and ammonia. Did you know that despite its vast size, 27 or remains unnamed because its orbit has not been determined with enough accuracy to grant it a formal name? Its dark surface and slow rotation make it one of the solar system's most elusive objects. The study of 27 or 10 includes both direct observations and computer models that try to guess its path and figure out what its physical properties are. To gather information, astronomers use both telescopes on the ground and platforms in space such as the Hubble Space Telescope. The light curves from these observations help us figure out its unusually slow rotation period. It takes about 45 hours to finish a rotation, making it one of the Kuiper belt objects that rotates the slowest. Just when you thought we knew everything there is to know about our solar system, discoveries like 27 or 10 come along to challenge our perspectives. But hold on, what we discover next about another distant celestial body might just redefine the impossible. This introduction to 27 or 10 not only sets the stage for a deeper look into strange celestial bodies, but it also shows how we are still finding new things in the outer solar system. Every piece of information we get helps us learn more about these faraway worlds and the universe as a whole. Ultra-hot Neptunes are an interesting group of extrasolar planets that don't behave like normal planets. These objects in space circle very close to their stars, much closer than Mercury does to our Sun. This means that the surfaces of these objects can get very hot, over 1,700 Celsius, 3,092 F. Being so close to their host stars challenges what we think we know about how planets form and how they stay alive, because it can lead to atmospheric blow-off, which is when the atmosphere is actually ripped away by the radiation and winds of the star. To give you an example, think about Kelt 9b, a very hot Neptune that is so hot that molecules like water can't form and instead break down into atomic hydrogen. Observing these planets not only tests what we think we know about atmospheres, but also how well our existing models of putting planets into groups work. Extreme conditions bring up important questions about the variety and strength of planetary systems all over the world. If you compare ultra-hot Neptunes to other types of planets, what do you think the reasons are? Their scarcity might have something to do with how they formed and the conditions that had to be met to make such harsh settings. Are you interested in the secrets of 27 or 10? Just wait until you hear about I-134134. What scientists found around this very large star could be the key to figuring out how celestial giants form. This change from talking about very hot Neptunes to talking about I-1341 to 34 suggests that we will continue to look into the strangest and most extreme things in the universe. Each topic builds on the previous one, focusing on the new discoveries and surprises that keep happening in science and make us question what we think we know. I-134134 is a very big star in the very deep parts of the constellation Centaurus. A new study of this star has shed new light on how complicated star formation is. This huge cosmic body, which is about 20 times the mass of our Sun, has called into question the idea that big stars are usually made when smaller stars crash into and merge with each other. Instead, the finding of a large disk of gas and dust orbiting I-134134 suggests that even the biggest stars might form in the same way that smaller stars do, by slowly gathering matter from a protoplanetary disk. Such a result has very important effects. It's not just a flattening nature. The disk around I-134134 is moving and full of complex biological molecules and dust particles that interact with each other as the star's gravity pulls them together. Even in these harsh conditions, this interaction could cause planets to form, which could mean that scientists can look in more places for new worlds and maybe even life. Astronomers can improve their models of how stars grow and change over time by learning more about the disk's properties. I-134134's strong brightness and the gravitational pull of its mass make it a unique place to study how matter acts in some of the galaxy's most energetic areas. This study is very important for both mapping out the life cycle of stars and looking into the possibility of planets forming in places that were thought to be too unfriendly before. Our next topic is rogue planets, which includes both the exciting environments of big stars like I-13T41TD34 and the mystery planets that wander the universe. These mysterious bodies, which float in space without a star to circle around, make us think about what a planet is and where they can live. Rogue planets are both mysterious and instructive. They are a new frontier in our search for knowledge about the world. What do you think happens to a planet that isn't held in place by the gravity of a star? We'll find out with our next subject, which is rogue worlds. We move from talking about huge star systems like I-3D40134 to talking about dangerous planets. This is one of the most interesting topics in astronomy. These are celestial things that float through space without being pulled by any star. They are also called rogue planets or free-floating planets. This is very different from the usual idea of planets as things that circle stars in a clear solar system. These strange space travelers aren't held back by the gravity of any star, so they move through the sky by themselves. Their finding goes against the usual ideas about how planets form, which say that the gravitational pull of the star is needed to gather and shape planetary bodies. Rogue planets are thought to form in one of two ways. Either they are thrown out of their home solar systems by gravitational pulls, or they form on their own in a cloud of stars that are still growing but never join with a star. Rogue planets are especially hard to find, and means like microlensing are often used to find them from Earth. This happens when the rogue planet briefly shines brighter than a faraway star as it passes in front of it. These events are rare but useful chances to learn more about the features of these wandering planets. Planets that go off course have huge effects on our understanding of the world. They show that planetary systems may be more complex and changing than we thought, and that the right conditions for planet formation can happen in more situations than just those where planets circle stars. Also, the sheer number of these planets, possibly more than the stars in our own galaxy, points to a huge hidden population that challenges our ideas about how common and spread out things are in the universe. It's possible that these flying worlds are more common than stars, which brings up interesting questions about the possibility of life in these harsh places. Could life exist under a thick layer of ice that is heated by geothermal heat on a planet that is moving through the cold space? The possibilities make us think outside the box and push us to find better ways to identify things as we continue to explore space. Studying rogue planets not only helps us learn more about how planets form and how they stay alive, but it also opens up more options for our search for life beyond Earth. Now, let's turn our attention to an interesting area of cosmic study that looks directly into how life began. Complex organic chemicals have been found in the protoplanetary disks around young stars by new studies. These molecules, which are sometimes called the building blocks of life, are made up of different carbon-based substances that are necessary for life on Earth as we know it to begin. Protoplanetary disks are thick areas of gas and dust that form around newly formed stars. They are where planetary systems start. Complex organic molecules have been found in these settings that are always changing. Molecular building blocks like amino acids and simple sugars are made through chemical reactions sped up by the young star's energy and different activities in the disk. These molecules being found in protoplanetary disks is important because it means that the building blocks for life may be spread out across the universe inside the disks that finally come together to form new planets. This means that conditions that are needed for life to start happen very early on when stars and planets are being formed. You can think of a protoplanetary disk as a huge kitchen in space where different materials are mixed together to make a recipe. The disk mixes gas, dust, and organic molecules under the impact of stellar energy, similar to how a baker mixes flour, sugar, and eggs to make a cake. This could lead to the formation of planets that can support life. This cosmic recipe sets the stage long before planets even fully form. This means that if life starts to form on a planet, its basic building blocks were probably set in motion very early on in the life of its star. This finding not only helps us learn more about where life might start, but it also opens up the possible habitable zones to include a wider range of planetary settings. We no longer have to look for planets with life on them. Now we can think about how life could begin in the space between the stars. The study of complex organic chemicals and protoplanetary disks leads to new ways of looking for life beyond Earth and raises interesting questions about whether the building blocks of life are the same everywhere. We learn a lot about the conditions that might allow life to start everywhere in the universe as we continue to study these cosmic homes. As we continue our look into the strange, let's look into the strange things about Kepler-78b, a planet that by all accounts shouldn't exist based on normal ideas about how planets form. This extrasolar planet not only questions our scientific ideas, but it also captures our imaginations with features that are similar to Earth. It changes what we think is possible in the universe. In just 85 hours, Kepler-78b makes a full circle around its star, which is much closer than Mercury is to our Sun. Because they are so close, the surfaces are very hot and wouldn't be good for life as we know it. The thing that really confuses people is that its makeup and mass look eerily like Earth's. This makes it seem like Kepler-78b is a rocky planet with a big iron core. This makes me wonder how such a body could have formed so close to its star without being destroyed. The fact that Kepler-78b exists changes how we think about how planets form. According to the latest models, planets are thought to form in the cooler outer parts of a star's protoplanetary disk. They may move inward but not as close as Kepler-78b found. Its findings suggest that there may be unknown processes at work that can make rocky planets in situations that were thought to be impossible before. Even though Kepler-78b is in a harsh environment, its makeup makes it seem like it might be connected to Earth because the two planets have a similar structure. This similarity has big implications for the study of exoplanets because it means that worlds like Earth might exist in a lot of different orbits, some of which we haven't even thought of yet. Imagine a planet that doesn't belong in the universe but is still spinning through the stars, despite our best efforts to explain it. As we come to the end of our journey through the universe's most mysterious parts, let's think about how these new finds might change the way we explore in the future. This reflection sets the stage for the end of our exploration and stresses how important these results are for broadening our views and pushing the limits of what we think is possible in science. Assume you are an expert who is looking into Kepler-78b. What kinds of studies do you think should be done to find out more about this strange planet? Leave your thoughts below. As our trip through space continues, we move from the mysterious Kepler-78b to the fascinating world of white dwarf stars. White dwarfs are some of the coolest things in space that are classified as stars. They help us learn more about the universe by connecting the features of the coldest stars with those of gas giant worlds. White dwarfs are a type of brown dwarf. Brown dwarfs are things that are not stars but are in the mass range between the biggest gas giants and the smallest stars. These brown dwarfs don't have enough mass to start hydrogen fusion, which is what gives real stars their power. White dwarfs are very interesting because their temperatures are very low. They can be as cool as room temperature, which is about 25 degrees Celsius 77 degrees Fahrenheit. On the other hand, the surface of our sun is about 5,500 degrees Celsius 9,932 degrees Fahrenheit. The discovery of white dwarfs questions the usual ways of putting celestial bodies into groups. Our understanding of what a star is has grown since their discovery, mostly through infrared surveys like those done by the Wide-Field Infrared Survey Explorer WISE telescope. This has implications for understanding atmospheric compositions in a wider range of conditions than we thought possible before. Scientists can study atmospheres of white dwarfs that are cool enough to have water clouds and other complex chemical molecules that are usually found on planets, not stars, because of the way they are made. This one-of-a-kind trait gives us information about both stellar and planetary processes, confusing the lines between the two groups and helping us understand more about things that happen in space. The study of white dwarfs not only helps us learn more about how stars grow and what their properties are, but it also helps us find places where life might be possible that we wouldn't expect to find them. As these objects get closer together, the line between planet and star becomes less clear. This makes us think about where life might grow or already exist in the universe. In conclusion, white dwarf stars show how different and far-flung our universe is. They fascinate us and help us learn more about it. They tell us that the universe is a huge and amazing place full of things that don't fit into any simple categories and are always pushing the limits of what we think we know. This study of white dwarfs sets the tone for our final thoughts, which are full of awe and wonder at the complexity of the world we are trying to understand. We have now reached the end of our journey through some of the most mysterious and interesting parts of the universe. We have seen rogue planets drifting without a star, looked at the complex organic molecules and protoplanetary disks that may contain the building blocks of life, been amazed by the mysterious properties of Kepler-78b, and gone deep into the cold but fascinating world of white dwarf stars. Each of these topics makes us think, pushes the limits of what we know, and shows how different and complicated our world is. The discoveries we've talked about today, like planets that don't fit our current models of planetary science and the possibility of life in places we didn't expect it to exist, show how mysterious and interesting space travel is. These things show not only how big the unknown is, but also how many amazing things we could find in the future. Feel free to leave your ideas and thoughts in the section below. What did you find most interesting about today's exploration? Do you have any thoughts or theories about these strange things happening in space? Join the conversation and be a part of this exciting discovery trip. Remember to subscribe if you want to see more videos like this one. Every new thing we find in space tells us something important about the universe and our place in it. The things that keep us going are your interest and desire to learn more about these cosmic secrets. Thanks for watching, and don't forget to keep looking up. You never know what secrets the next night sky might hold.